Hello everyone. Welcome to today's video. In this video, sorry, in this session, we are going to uh, get to know about how to integrate AI in the field of hospital. So this project is related to hospital administration, where we will try to integrate AI solution into hospital administration so that we can solve their business problem. Now, so first we will discuss about what is their business problem. So let's start with hospital business problem. Now, uh, in many hospital, data is stored in different places. It might be stored separate data set is there for pharmacy, separate is for finance, separate is it is for clinical and operations. Because of this, everything becomes slow and disconnected. Now, we don't know how clinical department work. We don't know how finance department work or pharmacy or operational. One department don't have any clue regarding the other department. So our business problem is we don't have that much of connectivity between the department, which leads to delay in processing, which lead to delay in decision making. Now come to the objective of the business. Now, while talking about objective, we need to maximize the real-time operational visibility. So if something happen in clinical, pharmacy or operational department, we need to update that particular thing in real time. So if someone from any other department will come and see it, they can easily understand what is going on another department. So there are a few things that we have to keep it in mind. Like one department cannot see the other department operation. We need to resolve. Manager do not get real-time information. Decision take more time. Like of course we need to have more time while taking decision. Here forecasting for different product. It might be related to medicine. How much medicine do we need to purchase? How much medicine do we need in next month or next week? So that forecasting, predicting the future will be difficult if there is no connectivity between different multiple departments. It might be possible that resource may not be used properly. There are few beds which might be vacant. We need to occupy it. If we don't have real information related to hospital bed available, so we can't make an optimal decision. We can't make optimal resource utilization. And uh, like if you are not integrating real time or AI solution into it, then hospital cannot watch performance in real time. That is the main problem. So we can solve this problem by maximizing real-time operational visibility and minimizing decision-making delay. Now let's talk about business constraint. So we need to have some sort of limitation while going through a project. We can't like there can be resource limitation. There can be department limitation. There can be time limitation. So here we have to focus on few things. What are the how to maximize system requirement? How we are supposed to uh, maximize it, and how to minimize data integration complexity, because there are multiple departments. See how many departments are there. From those multiple departments, we will get multiple different data. Integration of those data is very really complex. So we need to minimize data integration complexity. Now let's talk about business success criteria. So we have to focus majorly on three departments, that is finance, pharmacy or clinical. And we need to create an interactive dashboard that it should be a real-time dashboard, which give us real-time information related to different department. What is the key benefit of having this dashboard is we have a faster decision making, better resource allocation. Now we can allocate multiple resource. Sometimes there might be more resource get allocated in one department. So if we are having real-time information regarding this, then we can easily allocate it to another department. We also have we will get benefit of proactive performance and demand forecast. Now let's talk about economic success criteria. When we talk about economic success criteria, we are having at least 30% reduction in manual reporting time, because we have to report uh, each department individually, and that too manual task. So by using this real-time dashboard, we can reduce this manual manpower. So we have to, what we have to focus on? We need to focus on the integration of data from multiple different sources, and we need to create a real-time data visualization so that if someone will come and look into that dashboard or visualization, they can get information from multiple departments. Now the department might lie on clinical, pharmacy, finance, and operation. So this is my business problem, and these are all constraint, business objective, and success criteria. Now let's talk about, once we completely understand the business problem, we need to focus on the data set. Now we have data set. We have two primary source of data set collection. Like first is primary source, second one is secondary source of data collection. So we have followed both process. Few of the data set we got it from client. Few of the data set we scrape from different website, multiple different websites, so that we can perform this operation clearly. So let's talk about the data set. So this is my data set where we are having SKU master, like stock keep unit. How many stocks we need to keep? Stock of medicine, what medicine is required, how many medicine it is required for next week or next month. We need to keep all these things in mind. So we are having multiple different columns to consider. That is stock ID, what is the medicine ID, stock code, the name of the medicine, what category it belongs to, what subcategory it belongs to. Like it might belongs to certain group of medicine, and within that group of medicine, in which subcategory it belongs to. Then we are having multiple different other features to consider, that unit measurement, standard cost, and many more. In the same way, we also have another data set which is related to transaction. First one is related to medicine information, like what kind of medicine we are having, how many medicine required, what is the name of the medicine, which category it belongs to, which subcategory it belongs to. Now, second one is related to transaction line. Here we are having transaction ID, transaction code, hospital ID, in which hospital that medicine went. What is the department ID of the medicine? What is the pharmacy of that medicine? From which pharmacy we get this medicine? What is the patient ID, like which patient we have given this medicine, what is the pill ID, prescription detail, because without prescription we can't give this medicine. Then we are having transaction time, like what could be the transaction time, what is the price of medicine, what is the price of group of medicine, and uh, and this revenue related to a particular medicine, what could be the revenue that we can generate by considering that medicine. So there are many more features that we have gathered. Some of the data we get from our client side, some of the data we have scraped from different multiple hospital website so that we can get to know what could be the suitable features to consider while creating this project. Now, once we are familiar with source of data, once we are familiar with uh, what could be the business problem, how we are supposed to solve it, let's look into the architecture diagram. So if you look into this architecture diagram, I have created very simple and intuitive architecture diagram, which uh, anyone can understand. So if you look into the data architecture diagram, here we are having a source of data collection. Now we have already discussed that we are having two different source of data collection, that is primary source and secondary source of data collection. Now, when it comes to primary source of data collection, we need to scrape data from multiple different websites, integrate it, look into what could be the primary key, what could be the foreign key. So we also have, like I have also created this information, like what could be the primary key related to the data set, what is the different data type, what is a like quality check. We also have to consider it mind quality check in the sense that what if the medicine uh, like what if the medicine it's written quantity of medicine, and what if there is a negative number -1 -2 -3. So it's not possible to have quantity of medicine in negative number. So you have to keep it in mind that it should not be negative. In the same way, you also have to keep in mind related to the quality of each and every features to consider. The quality might be positive, the quality might be negative, the quality might not be in decimal. It must be in integer value. It must be whole number. And what could be the linkages of the data set? How to connect one data with another data? We need to keep this kind of things in mind. Now, once we gather all this information, let's look into the architecture diagram. So once we get the data, we need to perform some sort of task so that we can convert it into structure format. Now, once we get the data in the structure format, we have to load the data somewhere. Now, that somewhere database can be anything. It might be your local MySQL database. It might be present in S3 bucket. It might be present in uh, MySQL that is in AWS. There are multiple different sources from where we can put the data set, and we can create that database. Once the data is get stored in database, it might be MySQL, it might be Postgres, it might be timescale DB. Once this gets stored in the database, we will get this data. Now this is a raw data because we have not performed any cleaning operation. We have not removed outliers. We have not performed uh, missing value treatment. So once we get this raw data, we will perform EDA and data cleaning operation. Now when it comes to EDA, we will look into what could be the descriptive statistics of the data set. What could be the mean of the data, median of the data, mode of the data? What could be the standard deviation of the data set? What could be the variance of the data set, whether the data is skewed or not? If it is skewed, how much it gets skewed? Like whether it's a positively skewed or negatively skewed, or it is a right skewed, that is normal distribution. Then we also have to check uh, look into the data cleaning process. Now, once we come to the data cleaning process, there are multiple different process of data cleaning. First, we will talk about typecasting, whether the data, whether all the features are present in proper data type or not. Once we look into typecasting, then after we will look into missing values, whether the data consists of missing value or not. Now, if the data consists of missing value, we will go into imputation technique. So there are multiple different types of imputation technique: mean imputation, median imputation, mode imputation. Then we are having feed forward imputation, feed backward imputation. Once imputation is done, then we will also look into whether the data consists of duplicates or not. If the data consists of duplicate, it's not proper to have that data. We will try to remove the duplicate. Once the duplication is done, then we will try to check whether the data consists of an outlier or not. If the data consists of outlier, then we will perform different technique, like we will look into 3R technique: rectify, retain, remove. Now, if the data consists of outlier, what if we need an outlier? What if that we need an outlier? So we will retain it. What if the data consists of outlier, but I need that data. I don't want to remove that data because data is very precious. Then we will go for rectification. Now for rectification, we will look into winsorization technique. Once this is done, what if the data consists of 1 lakh of record and only one data is an outlier? So we will not focus on performing rectification of that data. We will simply remove it. So these are all 3R technique: retain, remove, and rectify. Once this rectification, removal of outlier or treatment of outlier is done, then we go with uh, transformation technique. Now we are having multiple different transformation technique, like Johnson transformation, Box-Cox transformation, reciprocal transformation. Once this transformation is done, so why we are performing transformation? So that we will try to convert our data into normal distribution, because it's very easy for a model, or it's easy for us to visualize the data if it is normally distributed. Once it's done, then we will look into whether all the EDA and pre-processing step is done or not. Then we will look into visualization tool. Now here you can go with any visualization tool. Here we basically use Power BI for visualization. Once visualization is done, then it's very easy for us to perform decision making. Now, all this process I might think, like, it's very simple process that we have performed over here. Now, once this process done, then we will look into the visualization that we can perform. Now, like it is not a proper dashboard. Here we are working on report. So this is report that we can create by using our data set. So we can look into annual budget, what is the total cost required, what could be the total spending that we are doing, what is the total quantity of medicine that we have purchased, how many total beds are there. So right now it is showing 800. It might be possible that after some time it might show 750 or 780 or 798. It totally depends upon the real-time change of the information. Now we can also look into this funnel chart, which showcase what age group of person are there. So like most of the middle age group person is there, like 0 to 18 it's a little bit less, than 35 to 60 it's keep on decreasing according to the age group. What could be the sum of spending that we can look into for a particular department? So if from here you can conclude that cardiology is having more revenue as compared to other. Second is internal medicines that the company sold. From here we can extract multiple different information, like bed count, how many bed counts are present in different department. Like if you look into this, this particular department consists of 80 beds. This particular department consists of 80, 64, then 56, and then 40. Like neurology consists of very less number of department. So in the similar way, we can also look into the different other reports, which we can easily convert into dashboard. Once we sign it, put it all this information into my dashboard, then it will look little bit easy. So there are multiple department you can look into this. the instant type, we are having government, private, or self-pay. There are multiple different types of hospital can look into. So there are this three particular type department is there. We are also having different multiple age group of people, and we also can show what is the admission date within this to this. We can also reduce or increase or decrease. With the increase or decrease, we can change the value like within this particular range, 0 1, like let's consider for 5 months. Now for 5 months, how many admission is there in hospital? What, what could be the occupancy rate in May, April? See, if you look into this, I have changed it from first like January to May, and it gave us information related to January, from January till May. So here also, if we increase or decrease, it will give you the information like this. Now it is showing from January till December, and total number of days by year, like in 2024, this many patient came. 2025, this many patient came. Sorry, 2023, this many patient came. So accordingly, we can also create a line chart which showcase this information, and we can also create a bar chart. So from here, we can conclude that it give us real-time data information. If something gets changed in the database, if some modification happen in the database, we can it can get like it will get reflected here in the dashboard. So this is all about my hospital analytics project, where we first discuss about what is the business problem of the data of the hospital. How by using AI solution, by integrating AI solution, we can easily able to resolve this issue. Then we discuss about the metadata. Here we have consider only two different data set, but in real world scenario we can have 15 or 16 multiple different data set to consider. And by considering this, we can also consider primary key, what could be the data type of particular data, quality of data, and linkages. Once this is done, then we will we proceed with the architecture diagram, where we get to know what could be the primary and secondary key, how we are scraping data from multiple different websites, or we are getting data from the end user, that is client, and then we integrate all data, put it into database. Now this database can be like MongoDB, Postgres, yeah, or MySQL. There can be multiple different platforms where we can store data. Now data might be locally stored, or it might be stored in AWS or GCP or Azure. And then we perform cleaning operation, and then we look into visualization. And at the end, we have created a real-time dashboard like which get changed according to the updated data. Now, if the database will get updated accordingly, it will get reflected. So this is all about my project. I hope you enjoy this session. Thank you, everyone.